As our reliance on technology reaches new heights every day, millions of new fiber connections are being made, both fixed and wireless. But there's also significant untapped connectivity potential in existing networks. And Dura-Line is here to help you get the most out of your current infrastructure. Microducts provide permanent protective pathways for miniaturized fiber cables. They're installed quickly and easily to unlock new pathways in legacy ducts, whether they're empty or already contain cables. There are two main methods of installing microducts in an existing duct, whether you are subdividing an empty conduit or performing an override of an existing cable. The first is mechanical insertion, which uses a winch or powered rod to pull the microducts. And the second is air jetting, which uses high-speed air to propel the microducts into the conduit. Choosing the best microduct installation method depends on the size and material of the existing duct, the space available inside, and the distance you need to deploy. If the duct is made of PVC, transite, or terracotta, you will need to winch pull or power rod. These materials are prone to cracking, which prevents a duct from being pressurized for air jetting. If the duct is made of high-density polyethylene, or HDPE, then it can most likely be pressurized for air jetting. Generally, the smaller an HDPE duct is, the easier it is to pressurize. So, if the existing HDPE duct has a diameter of 2 inches or smaller, it should be possible to winch pull, power rod, or air jet the microducts. If the duct is larger than 2 inches, mechanical insertion is the most appropriate solution. So now we've learned how to assess an existing pathway. Let's look in more detail at the microduct installation methods, starting with mechanical insertion. Mechanical insertion is a long-established installation method, and the most fundamental variation is winch pulling. This technique uses a winch and capstan to draw the microducts through the conduit with a rope or pull tape. Winches are typically truck or bumper mounted, and most are quick and simple to assemble. To prepare for pulling, feed a rope or tape through the duct. This can be done with a common handheld leaf blower. At the winch end, position the rope on the winch assembly and route onto the capstan. At the opposite end of the route, securely fix a pulling eye to each microduct to be installed. Then, connect the pulling harness to the microducts via the pulling eye. Connect the harness to the pull rope via the swivel, which ensures the microducts will not contort during installation. Then start pulling the microducts back through the duct. An electric capstan will ensure a consistent force and speed. Although it is relatively slow, the ease and minimal setup requirements of winch pulling make it ideal for installations in larger, older duct structures over relatively short distances. Once the microducts reach the winch end of the route, pull them to the top roller and detach the swivel, harness, and eye. The microducts are now ready for microcables to be installed. A second, faster mechanical insertion method is power rodding, where the pull tape is replaced by a powered fiberglass rod pushed through the conduit by a tractor belt. First, attach the rear rod guide tube to the unit. This will help direct the pusher rod through the machine. Then attach the feed tube to the front of the unit. This will help direct the pusher rod from the machine into the existing conduit. Insert the pusher rod through the rear guide tube and into the front feed tube via the pusher tractor, and secure the rod in the tractor housing. Start the tractor and adjust the speed as appropriate according to the size of the conduit, the space available inside, and the complexity of the route. Then track the number of feet covered via the digital display on the tractor pusher. At the opposite end of the route, attach a pulling grip to each microduct. Secure each grip by applying a few inches of tape onto the tail of the grip and a few inches onto the microduct. Then attach the microducts to the end of the rod. To begin the process of pulling the microducts back through the conduit, guide them by hand into the duct. Reverse the direction on the tractor belt and watch as the distance decreases on the digital display, and the rod is rewound into its cage, aided by the guide tube. Stop when the pulling hardware exits the duct. Remove the hardware and grips from the microducts, then they are ready to accept microcables. Power rodding is typically twice as fast as winch pulling and can be particularly productive if installing microducts over relatively short distances of 1,000 feet or less. If the existing pathway allows, air jetting can enable faster fiber placement over longer distances than mechanical insertion. Jetting machines differ in size according to what they need to install, but most have two important features. 1. A drive system to propel or push the cable or microduct into the conduit. And 2. Apparatus that seals the existing conduit to direct high-speed air down the pathway that creates a viscous drag force on the cable or microduct. The air is supplied by a portable air compressor. In warm or humid climates, a chiller and water separator may be required to cool and dry the air for optimal jetting performance. If your existing pathway is empty, air jetting microducts is a one-step process which eliminates the need to rope or rod the duct before pulling microducts back through. To begin, place an end cap on the free end of each microduct, then pressurize the pathways from the other end of the length, typically attached to the side of the transportation reel. Inflate the microducts to between 90 and 100 psi to provide additional anti-buckling stiffness and crush resistance for air jetting. Typically, the same jetting machine can be used to air jet both microducts and optical fiber cables. However, to install more than one microduct at a time, specialty belts and inserts are required, and it is always recommended to install all your microducts at the same time to avoid twisting and optimize distance and speed. Load the microducts through the drive belt, the insert, and into the existing duct. Lower the belt, start the driver to provide an initial pushing force, then gradually add compressed air to begin jetting. Monitor the speed, pressure, and installed distance via the jetting machine's digital display. Then when the microducts reach the end of the route, turn off the jetting machine, depressurize the pathways, and remove the end caps. The microducts are now ready to accept microcables. Microducts can unlock multiple new pathways in an existing duct, even if it already contains a cable. This is thanks to an innovative installation method known as an OverRide, which isolates the existing cable so the duct can be pressurized around it. The size and number of microducts that can be installed in an OverRide depends on the space left by the existing cable. Dura-Line typically assumes a maximum fill percentage of 55%, where the calculation is the sum of the cross-sectional area of the existing cable and new microducts over the cross-sectional area of the inner diameter of the existing conduit, multiplied by 100. As with any microduct jetting deployment, specialized belts and inserts must be used on the jetting machine, and end caps must be placed on the microducts before each pathway is pressurized, somewhere in the range of 90 to 100 psi, to provide important rigidity. Attach a feed tube to the jetting machine to guide the microducts into the existing duct. Next, the existing cable must be isolated with a specialized piece of equipment known as a Y-block, which sits between the jetting machine and the entrance to the existing duct. Everything in a Y-block is divisible so that it can be installed around the existing cable. Place the cable and duct in the Y-block with appropriately sized seals. Then secure the feed tube to provide the connection to the jetting machine. Next, place the top half of the jetting machine pusher onto the unit and secure by hand. Then feed the microducts by hand through the pusher and feed tube into the existing duct via the Y-block. Finally, place the top half of the Y-block on the assembly and secure by hand. The air jetting process can now begin. Start the drive belt to provide an initial pushing force, then gradually add compressed air to start jetting. Monitor the speed, pressure, and installed distance via the jetting machine's digital display until the microducts reach the end of the route, ready for cable jetting. Air jetting can install fiber 2 to 3 times faster and further than mechanical insertion methods like pulling or rodding. The most important factor in choosing the right cable for your microduct is the fill ratio, which is calculated by dividing the outer diameter of the cable by the inner diameter of the microduct, multiplied by 100. A fill ratio range of 50 to 75% is recommended for optimal cable jetting performance. This means for a microduct with an inner diameter of 10 mm, a cable with an outer diameter between 5 mm and 7.5 mm will typically yield best installation results. Before air jetting can begin, it is important to proof the microduct to ensure any connections along the route are airtight and to rule out cuts, kinks, or blockages in the pathway. First, place an end cap on the far end of the microduct and gradually add compressed air to a pressure of 100 psi and maintain for 1 minute. Once complete, depressurize and remove the end cap. Remove the microduct from the jetting unit, insert a BB, then reattach. Turn on the air supply to approximately 30 to 40 psi to propel the BB through the microduct. Then capture it in a bottle or other suitable device at the end of the route. If using jetting lubricant, remove the microduct from the jetting unit and pour in the required amount of lube. Insert a small sponge into the microduct, then reattach to the jetting unit. Turn on the air supply to blow the sponge through the microduct, simultaneously lubricating the route, then catch the sponge as it exits the microduct. With the pathway prepared, place a metallic jetting tip on the end of the cable. This will protect the fibers and guide the cable more efficiently through the route, particularly any sections joined by couplers. Place an appropriately sized rubber seal around the cable, then insert the cable along with the seal and jetting tip into the unit. Ensure the cable insert is properly attached to the unit, then close the housing to secure and maintain alignment between the cable and seal. Start the drive belt to begin pushing the cable into the microduct. If and when there is a significant decrease in installation speed or significant increase in pushing force, gradually add compressed air until these values return to their original levels. This process of increasing the air pressure when the pusher slows or push forces increase is repeated throughout the installation process. Most jetting machines feature a digital display which allows the operator to monitor the installation speed and distance in real time. And some will produce a chart depicting jetting performance against specific key parameters. This may enable technicians to execute more effective troubleshooting or even improve installation efficiency across a whole network. Station an operator at the end of the route to receive the cable as it exits the microduct. Switch off the jetting equipment and remove the tip from the end of the cable. The cable can now be routed into a closure or stored in a handhold for future use. So there you have it, 2 installation methods that harness the power of microducts to unlock vital extra fiber pathways in existing duct networks without the need for construction work. First, mechanical insertion, which uses a winch or powered rod to pull the microducts. And second, air jetting, which uses high-speed compressed air to propel the microducts into the conduit. For more information, please visit Dura-Line.com or reach out to your local Dura-Line representative.